we are beginning to start proofs, real proofs. So algebraic proofs, we kind of looked at the properties of quality. Now we're going to start segment proofs. Notice, segment proofs reference. Reference means we're going to refer back to this. So always keep this in front of you when you're doing proofs. Remember that on the reason column, so proofs, two-column proofs have a statement and we have a reason. And the reasons can be postulates, definitions, theorems, and properties. Those are the four things that it can be. So you'll notice this reference sheet includes properties, postulates, theorems, and properties, and definitions. So the properties of equality, we did that last time. These properties may only be used with equal sign. Okay? Properties of congruence, we're going to talk about. But the properties of equality, you must have that equal sign in there. That's what we did the last algebra one. Here's my properties of congruence. Okay, reflexive property, we already know the reflexive property. It says that AB is congruent to AB. Okay? Now, you'll notice the congruency part. The congruency part is, look, we're talking about the length of a segment. Now we're bringing in congruency of a segment, which means I have the congruency symbol and I put that line above. So segment AB, remember, is measurement. This is congruency. Okay, this is talking about the congruency. And reflexive, we know it's the same on both sides. Remember those properties from algebra that I said we'd go back to in geometry? Hello, here we are. All right, so symmetric properties of congruence says that if AB is congruent to CD, then symmetric says CD is congruent to segment AB. And notice the congruency statements, we have congruency signals. Signals, what? Signs, sorry. Transitive property. All right, so transitive says that if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Notice, properties of congruence has to have a congruency statement. Properties of equality have to have that equal sign for an equal statement. All right, so some big definitions that we need to know. And I want you to highlight this one because sometimes students struggle. So now we really need to highlight definition of congruence. So segments are congruent if and only if, by conditional statement, which means two times, if they have the same measure. Okay. Segments are congruent if and only if they have the same measurement. So watch what I have here. If AB is congruent to CD, then the measures are equal. Then AB equals CD. Okay? And remember, it's biconditional, so it goes both ways. If AB is equal to CD, then AB is congruent to CD. Definition of congruence. So definition of congruence means they're congruent, which means they're equal in length. And if they're equal in length, then they're congruent. Okay? Definition of congruence. Definition of midpoint. We already know what the midpoint is. It says the midpoint of a segment divides a segment into two equal congruent parts. If M is the midpoint of AB, then AM equals MB. Definition of midpoint. And again, you can look at that picture, AB, and here's M. And because we're talking about measurement, it's not congruency, it's the measurement. Midpoint means equal, or congruent parts. I can put that in and then claim definition of congruence. All right, here's my postulate. My postulate says, segment addition postulate says if A, B, and C are collinear and B is between them, then we already know this. AB plus BC equals AC. We already know that. We've already been over that one. Okay? Now, let's take a look at this. I don't know if you have this in your folder. I don't know if I gave this to you, but let's see if you can guess it. If PQ is equal to PQ, then PQ is congruent to PQ. Definition of congruence. That's definition of congruence. If K is between J and L, then JK plus KL equals JL. That is your segment addition postulate. Reflexive property. Reflexive property of congruence. Reflexive property of congruence. If it were this, it would be reflexive of equality. Here it's reflexive of congruence. All right, so if RS equals TU, then RS plus XY equals TU plus XY. So notice here, if I wanted to end up with RS and TU, all I would have to do is subtract XY on both sides. So this is subtraction property of equality. Subtraction property of equality. I'm only abbreviating because I don't think you have this in front of you. All right. Oh, what am I doing? What am I doing? No, that would be if I solved it. This is addition property of equality. Sorry. Addition property of equality on this one. All right, number 5 is going to be symmetric property. Symmetric property. Number 6, if y is the midpoint, then xy equals yz. That's the definition. So it's telling us a midpoint. That's definition of midpoint. Number 1, that's going to be your, or 7, excuse me, that's going to be your transitive property. Transitive property. Number 8, if AB plus CD equals EF plus CD, then AB equals EF. That is going to be your subtraction property. If number 9, if PQ plus RS equals TV and RS equals WX, then PQ plus WX equals TV. So everything looks the same except this RS and this XY, but it's introducing RS is the same as WX. So that's substitution. That's going to be a substitution property. If LP equals PN and LP and N are collinear, then P is the midpoint of LN. So that is going to be definition of midpoint. P is the midpoint of LN, definition of midpoint. Number 11, they're congruent, which means they're also equal in length. That's congruency property, definition of congruence. Definition of congruence. And then here, CD, how are they getting DE to the other side? They're subtracting DE from both sides, so subtraction property of equality. So that is what your properties look like.